Hi friends, in this tutorial we are going to talk about some system design interview. So if you are applying for jobs related to machine learning engineer, data scientist, lead data scientist, lead data engineer, this problem is pretty common. And they will ask you a question like design a scalable data platform on Azure for processing 1 terabyte data in a day. Okay, so in system design round, you have to basically design the complete system from the end to end. The ETL pipeline basically extract how you are extracting your data, T transformation, how are you transforming your data, what type of tools you are using, and then load, where are you loading your data. Okay, so the first thing is don't directly go and start designing your solution. Okay, in any system design interview round, the first thing is you have to be clear with the questions. Okay, so you have to ask questions related to functional requirements and non-functional requirements. Okay, so first understand what is the functional requirements and what is the non-functional requirements. Okay, so functional requirements states like what actually is asked you to design, how your system should work. Okay, so anything related to functional test. Okay, like how you are doing your data ingestion, how are you doing data transformation or validation or cleaning, or where are you storing your data, and then how are you serving your data, what is your tools you are using for the data visualization, if there is any machine learning and analytics is involved, how are you doing that. Okay, and finally governance and access control. So these are the things will basically define your functionality, whether your functionality works properly or not. Okay, and then the second thing is non-functional requirement, means they are not directly impact the functionality, but they are needed to design a great system. Like scalability is like whether your system is scalable if all of a sudden lot of load comes. Okay, so whether your system can is agile enough, is flexible enough. Okay, how the performance of your system. Okay, then whether your system is if highly available or not, whether your system is fault tolerance, if any region or if any fault comes. Okay, whether your system can work on the other region. Okay, then what type of security your system is using it. Okay, if the data is in the rest, what security you are using it, if the data is on moving data, then what security you are using it, and then not the least monitoring and cost optimization. So these type of topic things you have to talk about. Okay, so functional requirement and non-functional requirements, the first thing is in the system design round you have to ask the questions. Okay, and clarify your requirements. Okay, it's very much clear, don't assume anything. Okay, even if you are assuming anything, you have to tell to the interviewer what you are thinking in your mind. Okay, so the first question, because you are going to design an ETL pipeline, so the first question is whether the data which comes to you, whether it's a batch data or whether it's a streaming data or whether it's a both data, because for the ingestion what type of tool has to be used, it depends on which type of data is coming. Okay, good. Second thing is latency. What is the latency? Whether if it is a real-time data, so immediately we have to put it. Okay, if it is a batch data, then definitely you have some bandwidth when you can ingest. Okay, so what is the latency of the data? Then who are the consumers? Okay, so accordingly you can create a data visualization platform like I say BI dashboards. Okay, whether your consumers of your data is only the business people, they are interested on machine learning models, so who are your consumers? Then you have to also talk about the data retention, how long the data has to be there in your if you are using the AWS platform in S3 bucket or in Azure Data Lake system. And then finally security. So you have to ask these questions from your interviewer so that you will get more clarity. So this serve two things. The interviewer think you are not directly jumping into the problem. You are first analyzing the problem, different type of scenarios. Even if it is a ETL pipeline, the data could be a batch data could be a streaming data. So you are asking the right question. Okay, you are asking the question, if the data you are storing, how long the data has to be there. Okay, do you need to create some sort of a data archival policies around that. Okay, and if you are assuming something, just put it over there. Okay, so per day 1 TB of data is coming, a peak transaction is 20,000. Okay, and must be highly available and multi-region disaster recovery. Okay, now let's go one to one the complete architecture high level. Okay, so here I am giving you the high level architecture, each and every layer, and then we will go each layer in little in detail. Okay, so the first thing is ingestion layer. Okay, so if your data is a real time and if your data is a batch process, if the data is a batch process, then Azure Data Factory is one of the best tool. Okay, this tool basically it copies the data from one source and put the data into the another destination. Okay, so Azure Data Factory is a good tool if the data is coming in the file format in the batch form. But at the same time, if the data is a real-time data, maybe data is coming through a streaming platform, okay, or data is coming through the from API, you have to use Azure Event Hubs. Okay, now the next thing is you are able to ingest the data. Now the next point is storage. Where are you going to store the data? Okay, so the cheapest form of the storage is Azure Data Lake solution. Okay, so you store all the raw data into your Azure Data Lake. Okay, delta lake format, and here you have to also talk about you are going to use the data storage as a medallion architecture, which is called bronze, silver and gold architecture. Means your raw data which comes over there, that's the bronze, you can consider as a bronze. Then you do the processing of the data, you do the data transformation, you do null value checks, you change the columns, you delete some columns, you keep some columns. Okay, so you do all sort of data processing. Okay, that data you will put into the another data lake solution called as a in a Azure Data Lake, that's called as a silver. Okay, and then third, the data which is basically used for only for the analytics purpose. Okay, the data in the Parquet format, that you keep it in the Azure Synapse. Okay, and that is called as a gold architecture. We will come by one. Okay, so that the third layer is processing layer. So understand, ingestion layer, storage layer and processing layer. Ingestion layer can be two tools you can use, depends on how the data is coming. If the real-time data is there, then Event Hubs. If the batch type data is there, Azure Data Factory. Okay, storage layer, you want to put it very cheap, you use the Azure Data Lake solution. For processing layer, you are going to use the Azure Databricks. Why do you use Azure Databricks? Okay, understand, Azure Databricks is a very powerful platform because it is based on the Spark. Since it's based on the Spark is a distributed computing. Okay, so Spark can work on the multiple computers together. Okay, and so if your data is like 1 TB of data, which is like a very large amount of data. Okay, so to process that data, what you are going to do it, you are going to use any platform which can handle 1 TB of data in a day for a data transformation. And for this type of thing, the best platform is the Spark, and Azure Databricks is based on top of that. Okay, so you use the Azure Databricks for the data processing. Okay, you can do structured streaming for the real time, and you can also do the batch ETL jobs. Then the next layer is a data warehouse layer, where you are after converts processing the data. So your data may be coming in a different format, from the CSV format, from the text format. Okay, and through the processing layer, you convert that data to a Parquet format. Okay, a columnar storage. Okay, and that data you put it into the data warehouse solution. Basically, that's the Azure Synapse. Okay, Azure Synapse is a Azure service offering for doing the large amount of data analytics. Here a question can come, why can't you keep the data again into the Azure Data Lake and then you can do analytics on top of that? Okay, so the answer is, when you are doing analytics in a large amount of data, the first and foremost requirement is your performance must be very good. Okay, so you because here you are dealing in the data in a terabyte scale. Okay, so there only Azure Synapse comes into the picture, because here the performance is very high. Okay, even if it is a little costlier, but your performance is very high. So for the final data, the goal data, you put into the Azure Synapse. Okay, now the next layer is machine learning layer. So if you want to create some machine learning model, like suppose you are getting a claims data and you want to analyze whether the claims is a fraudulent claim or it's a genuine claim. So you may want to create a classification machine learning model. Okay, so that's the next layer. And the sixth layer is a serving layer. That is like how you are going to serve your data to the end customer. Okay, so there are different types of tools are there. So if you are using Azure platform, you will use Power BI. There are some independent tool called as a Tableau. You can also use REST APIs. Basically, you can just expose your data through the REST API. Okay, and the last and not the least, that's a monitoring and governance. Okay, so Azure Monitor. Okay, Azure Monitor for analysis of all the logs, log analytics, and Azure Purview for the data governance. Okay, so here I have shown you in a pictorial way the complete ETL pipeline. Okay, so if here there are the different sources from where the data is coming. So there are some OLTP databases, relational databases, basically transactional databases. Some data is coming in the form of APIs, some data is coming in the form of logs and events, some data is coming in a different files. Okay, CSV or JSON file. So all this data will come into the data ingestion layer, and here you are using the Azure Data Factory. Okay, so depends on whether it's a batch ingestion or whether it's a stream ingestion, you will use the tool. Okay, after when the data is ingested to Azure Data Lake, so the first thing is raw data, which is basically the branch standard, and then you use the Azure Databricks. Okay, what Azure Databricks will do, it will convert your branch data. Okay, it will convert your branch data, raw data, okay, to Parquet format. Okay, and along with that, if any type of transformation you want to do, okay, you want to do the null value check, you want to make sure the data is valid. Okay, so all sort of things you can do in Databricks. Okay, and then once your data is transformed, you put that data to the Azure Synapse for doing the analytics purpose, and here you have the Power BI tool which will be doing the data visualization. Okay, and then finally for the governance and security, so who will be getting the access to the data, so you can create some RBAC roles to get the access to the Power BI dashboards. Okay, for monitoring and alerts, you will be using the Azure Monitor. Okay, now let's come back. So I have explained the whole ETL pipeline in detail, but now let's go through each and every stage in detail. Okay, so the first stage is high level architecture, data ingestion. So what are the different sources from where the data is coming? First source is maybe transactional databases, then application logs. If it is logging data, so mainly it will be the streaming data. Same way, if there are some event streams are coming, Kafka event, then again it's a streaming data. APIs are also considered as a streaming data. And then there could be a batch file drops. Okay, so for batch files, And OLTP databases, such type of data you can handle using the Azure Data Factory, and streaming data like application logs and this APIs and event stream you can handle using the Event Hubs. Okay, so here you can see batch ingestion and real-time streaming. So let's go through little bit more detail. Azure Data Factory for batch ingestion, why do you use? It provides you the platform for the managing the orchestration, and it has got 100 plus connectors. Okay, so it has basically has got connectors to the databases, it has different types of databases, it has got connectors to the Azure data lake, you want to get the data from there, and so different type of sources you should be able to get the data. It supports the parallel copy activity. Okay, and real-time streaming data, you will use either the Azure Event Hubs for ingestion of the data, and if you want to do some analytics on top of that, you can use the Azure Stream Analytics. Okay, now the best practices. Okay, so when you are using the Azure Data Factory, put some best practices like use the partition loads. Okay, use staging containers. Okay, enable parallel copy threads. Here when you use the data in the form of real-time streaming data, the best practices are you can partition the data using the transaction ID, or you can partition the data using the date format, so it will be easier for you to query. Now the next layer is storage layer. We already talked about the raw form of the storage is going to be Azure Data Lake. Okay, why Data Lake? Because it's highly available, it's massively scalable, you can put like terabyte and petabyte sort of data, and it's very cheap because it's a blob storage. Okay, and it supports hierarchical namespaces, and it has got native integration with the Spark. And I talked about the medallion architecture. So in the medallion architecture, you get the raw data, you clean that data, make it a silver form, and then you put all the data to the Azure Synapse, which is basically data used for the analytics purpose as a gold standard. Okay, so bronze raw files, format Parquet, or it could be a CSV format. In the silver, the clean and deduplicated data, schema enforced, business rules are applied, gold data ready for the reporting. Okay, next one is a processing layer. Okay, and here we are going to use the tool called Databricks because it is based on Spark. Okay, massive parallel computing platform. Okay, so why do we use the Databricks? Auto scaling Spark clusters. Okay, the Spark cluster can be auto scaled. It has got Delta Lake support, it has got ACID transactions, and then optimized for the big data. Okay, batch processing, it's so Spark just the best thing about the Spark is you can compute in a terabyte scale of data very easily, very nicely. Okay, so batch processing. Okay, okay, now let's the next layer is data modeling and serving of the layer. Okay, we talked about for data modeling, basically when your data is you are going to put the data in Synapse. Okay, you partition the data mainly using the date, that's pretty common. Okay, so that it will be easier for you to get the data, not lot of so if anybody wants do some analysis in particular date, so it doesn't have to scan through all of the data set, it has to just go to that date and it can get the data. Okay, so that's why it's always good to partition the data using the date. Sometimes people are also partitioning the data using the transaction IDs also. Okay, then for the serving layer, one solution, Power BI. Okay, and you can also use the Azure Synapse Analytics. Okay, so if you want to do some sort of a query on top of a Azure Synapse, you can use the Azure Synapse Analytics. Okay, then for dashboards, you can use the Power BI. So this Azure Synapse Analytics, it's very similar to Redshift serverless. Okay, so serverless SQL. And yeah, next one is let's talk about the non-functional requirements. Okay, scalability. So the solution which you have used it, whether its a solution is automatically scalable. Okay, how much it is scalable. So the first talk about the Azure Data Lake solution. So Azure Data Lake is auto scales, highly available. You don't need to worry about that. Okay, so next one is a compute scalability. Spark clusters are auto scalable. Okay, and you can enable the auto scaling. So if the load goes high, it will automatically provision the new clusters in the Spark. Okay, so and in the Spark, there are in the Databricks, there are two. You can create separate clusters: cluster for the ETL jobs, cluster for the BI, cluster for the streaming. Okay, for the performance optimization, what you can do, the one thing always remember, you can always improve the performance by the partition. Okay, so you partition the data by date, that's a great thing. Second thing is broadcast joins. Okay, when you are joining your table, okay, if the table sizes are small, use the broadcast rather than the big inner or left joins. Okay, use the broadcast joins. Okay, avoid shuffle heavy operations. Okay, and cache hot data sets. Okay, so if data set is very much common, you can use the cache operation. Cost optimization, auto terminate the clusters, use the spot instances, and use serverless SQL whenever possible. Okay, at last, talk about the governance and security. So for governance, like when your data is there in Azure Synapse and you want to create the dashboard using the Power BI. So if you want to give access to your dashboard, use the RBAC roles, the first thing. Okay, and you can also use the Microsoft Purview. Okay, to view that data. So you can use the RBAC roles. You can get the row level of security in the data. You can also classify the data as a internal, external, consumer usage, like that. Monitoring and observability. The first thing is monitoring is Azure Monitor, which will basically logs everything for all the services. Then log analytics for any type of logs. Then Databricks cluster metrics. Okay, and you can create an alert for the job failure, or if any job gets failed. Okay, or data latency or throughput drops. Okay, so automatically alert will come to you. Okay, so final here the production architecture summary: ingestion, data factory or event hubs; storage, ADLS, Azure Data Lake solution; processing, Databricks in Spark or Delta; and serving, Synapse or Power BI; and security is Purview or RBAC roles; and monitoring is Azure Monitor. So this is the complete picture of system design of ETL flow. Okay, including both of the requirements, the functional requirement and non-functional requirements. So hope it clears. If you have any question, please write the question in the comment. Thank you.